So in this video, I'm going to introduce the basic structure of the multi-layer neural network. So here is a very general structure of the multi-layer perceptron. And here, let's explain all the components first, and then we can go details. And here we use the white dot here, the x1, x0. This is the white solid dot as the input. All right, this is the input. And similar, this one, this polygon, the white polygon as the input and the white polygon as the output. So the solid polygon. And use the black circle, the black dot with white circle. This one, this one, this one, and here as the neuron. The neuron, be more specific, is the processing unit. Just we do the multiplication summation at here. So this one is the neuron, and it's the processing unit. And use the white solid dot as the activation function. So this is the activation function. And here, of course, here as the activation function. So this is basically, the last one is the small white dot is the desired response. This is really the desired response. We compare with the output with the desired response, we get the error. So now we know all the components, all the symbol, all this, what does it really mean. One more time, the white solid polygon is the input, and of course that one as the error output, the white solid polygon. And the black dot with a white circle, this one as the neuron, that's the processing unit. And the white solid dot as the activation function. So this is all basically how this different symbol, what this mean. Let's start from left. Left one, the most left one is the input, x1, x2 until xm. So this is the input. Here we also add another actual input is x0 or x0. That one normally worked as the bias. This is same as what we did before. This is the bias. This is the true data input. So let's assume we have total xm, total sm input. And then move to the first hidden layer. Assume we have f neurons. That means we have f black dot. Some of them are using small one because I don't want to really plot f neurons here. And here, for any input, for example, for x0, its weight to the first neuron is the W01. Here's 1. The superscript 1 means that's for the first hidden layer. And here, this 0 means from the zero input, the index of input is 0. And next 1, this 1 means that is for the first neuron. Okay, that's the one. Let's go through here. Oh, no. What? Oh, I'm sorry for this. Okay, look at it here. So this one means the first hidden layer. And this 0 means the input is the x0. And this 1 means goes to the first neuron. So the first input to the second neuron is W102. This one, the superscript 1 means for the first hidden layer. The first subscript 0 means still from the 0 input, the first input. And the 2 means to the second neuron. Okay. Go back to here. For the second input, the x1, the weight for this one to the first neuron is W111. The superscript 1 means first hidden layer. This one means the first input. The second one means go to the first neuron. Similar for this one, the x1 to the second neuron, that's equal to the w1 and 1 and 2. 1 means superscribed. The first one means from this input, and 2 means go to the second neuron. Okay. This is all the synaptic weight, what this means. So since in the first hidden layer we have F neurons, so and the X and the total is M input. So for the last input to the last neuron is W1 MF. 1 means the first hidden layer, M means the M input, and F means to go to the F neurons. So this is how do we go to the first from input to the first hidden layer. So what happened in each neuron is for all the input, they multiply with their synaptic weight and then sum together at this neuron. That means the output of this neuron is equal to the x0 multiplied with w101 plus x1 multiplied with w111 and until the xm multiplied with w1m1. So this is the summation at here. This is the output here. Similar for other neurons. Okay, this is for the first hidden layer. And then the output of each neuron goes through a activation function. So here is a activation function. Activation function. So then we have the output. This output then multiply with the W211. Okay, this 2 means for the second hidden layer. And this 1 means the output from the first neuron. And second one means this one as the input to the first neuron of the second hidden layer. So similar for this one, you can get this one is multiplied with the W212. The superscript 2 means that's go to the second hidden layer. And this 1 means it comes from the first hidden layer, the first neuron of the first hidden layer. The second 2 means go to the second neuron in the second hidden layer. Similar, assume we have total has S neurons in the second hidden layer. The last one is equal to the W2FS. This 2 means let's go to the second hidden layer. This F means this one comes from the output from the F neurons, and S go to the S neurons in the second hidden layer. Okay, this is the first hidden layer and the second hidden layer. Of course, here you can have multiple hidden layer as long as you need it. And then the output of the hidden layer, second hidden layer, goes through the activation function. This is another activation function. And the output of this activation function multiplied with the third weight, that is W311. This 3 means go to the next third layer. And this one means it comes from the first neuron of the second hidden layer. And this one means go to the first neuron in the final layer. Similar, if we assume we have O neurons in the final layer, for the last one will be the W3SO. The 3 means go to the final layer. We only have 2 hidden layer and 1 final layer. Total is 3 layers. This S means this one comes from the S neurons from the second hidden layer, and O means go to the O neurons in the final layer. Okay, it's relatively complicated, so I want you guys to understand each of the weight, it's the superscript and the subscript, what that really mean. Otherwise, you are going to confuse in the later calculations. Okay, let's stop at the final layers. Here we have O neurons. And for each neural output, we will go through the activation function, the phi. So therefore, we have the O output. And for each output that compare with the desired response, So here D is the desired response. So as we know, when we compare the actual output with the desired response, we will get an error signal, E1. So for the last one, for the second neuron, we get the E2. And for the O neurons, the last neuron, we get the EO. And then the error function, the error signal will be used to adjust all this weight as we learned in previous chapter. Okay, so today in this video, we introduce the basic structure of the multi-layer perceptron.